Good afternoon, Anna, everyone. Yeah, good afternoon. All right. So, I think in the previous class we completed the cross product. Okay. Yeah. So, today we go to a new concept, none better. Okay, okay. But I think you are able to hear my voice. Yeah, yeah. That's better. Okay, no problem, Nana. Why? Because every day we are facing the same issue. Okay, maybe until we get the next update in Zoom. Okay. Right, right. Um, Here, when I come to new concept today, okay, before entering to get some idea, here what I'm asking, suppose what you learnt in motion in a plane and motion in a straight line. Uh, when, sorry, when, suppose a body is moving with uniform acceleration, then after certain time, if I ask the velocity is, you can say that formula. That is very easy. First formula, V is equals to U plus AT. Anybody can say. Means when the body is moving with uniform acceleration, how the velocity changes with respect to time. Means as a function of time. You set this equation. Better you use the earphones, Nana. Then you can hear the voice. Who is this Vishal? Why? Because nothing is there in my hand to do here from my side. Okay? Right. V is equals to U plus AT. And if I ask the okay now. And the displacement S is equals to, you usually tell UT plus half AT square. Means displacement you are telling as a function of time. One equation, and from this you are going to find out the displacement, how it changes with the time. Okay. And in the same way, if I ask the velocity after certain displacement, after a displacement, some displacement, okay, you say v square minus u square is equals to 2as. Means you are trying to say the velocity as a function of displacement. Okay. And that day only we concluded that all these equations are valid only when a body is moving with uniform acceleration. Otherwise, these equations are not valid. I think all of you remembered. Okay, I believe. I trust you all. Okay. But here problem is today if we go through the non-uniform acceleration, okay, means acceleration is not constant. Okay. In that case, how to find out the velocity as a function of time, the displacement as a function of time, and the velocity as a function of displacement. Okay, to find out those physical quantities, I'm going to use, okay, really one chapter from mathematics. Okay, they gave there in their mathematics, if one function is changing with respect to other, like example in mathematics, suppose generally they say x and y coordinates, Nana, in mathematics. Suppose they say y is changing with as a function of x, as y is equals to like 2x, if they mention like this. Okay, with what rate the y changes with respect to x. Okay, to find out, they said one method that is called as a differentiation. Who is this user? Differentiation. Okay, so here, if Nana, if anyone posted in WhatsApp, ask him. He just trying to enter with the name user. Okay, if they come like this, I won't accept. Okay, if you find any postings there in WhatsApp, you try to respond. Right? Just I did not admit him. He is there in waiting room only. Right, good. Then here, Nana, come to this differentiation method. Okay, what it says. First, try to listen. If you know, it is well and good in your 10th class. If you don't know, try to listen carefully. Why? Because it is completely a new concept. Okay, completely a new concept for others. That too taken, good afternoon, ma'am. That too taken from mathematics. Right? That differentiation method, which explains how the displacement or the y coordinate changes with respect to x and at what rate. Okay, that rate here is represented. This representation is very important, Nana. How we represent, okay, with respect to what it is changing. Sir, y is changing with respect to x, sir. With respect to x, na, then write here dx. Okay, next. Here, sir, it is changing, sir. Who is changing? Y is changing, sir. Okay, change. Represent with the letter D. Who is changing? Y. That Y you write here. Okay. Once again, I am repeating this one. How to write the differentiation? Okay. Observe. Here, first what I wrote, Nana? With respect to what it is changing as a function of x. Means when x changes, y changes. That's why with respect to x, y is changing. That's why the variable here I wrote in the denominator as dx. Okay, here you may ask one question. Suppose, sir, in the next example, if I write y changes as a function of t as y is equals to like some 2t square. How to write this one, sir? Very simple. If you understand, you can say in one step. Otherwise, once again, observe here. It is changing with respect. Okay, Nana Isha. No problem. Okay. Yeah. Shiva. Okay. And Snigdha. Okay. Right. Rate you observe here. Okay. It is changing with respect to time or t. Simple. Mathematics t. Right. With respect to t, it is changing now. So first write that in the denominator. With respect to t now, write it as dt. One term. Okay. Is it changing? Yes. If you change the value of t here, obviously y will be changed. So there is a change right here as a D. Okay, who is changing? Y is changing. So right here as Y. Okay, now all of you understood, Nana, how to write this differentiation? Or, yeah, that's what I wrote here, Mr. Pawan Kumar. Okay, so do you have any doubt writing the differentiation form? No doubts. Okay, good. Right, now I am asking here, suppose if I ask you one example. No, right, good. Now I am asking you all, in differentiation particularly, this is, you have to give the answer. Okay, be ready here. Suppose I am saying that some variable x is changing as a function of, say, some z, as a function of z, and given as x is equals to some like log z. Okay, so it is varying with the z, nano, who is varying x. This one, how to write that differentiation? Ah, very good, Pawan Kumar, correct. It's 100% correct. Others, how to write this one? Respond quickly. Yeah, Amog, correct. Others? Ah, okay. Oh, you are Lakshmi Gayatri, sorry. Okay. Yeah, very good. Deepali correct. Lakshmi Sujata correct. Lakshmi Satke. Yeah, I think all of you understood. So here I am writing this rate as, I think you understood, d by dz. Okay, Manikanta, too late today. D by dz of x. Very. So you understood the differentiation form. Okay. In this differentiation, while using in our physics, Nana, we require few formulae. Ah, yes, correct only, Nana. Rajuri, right? Means here, sir. Actually, first later you tell the formula, sir. In differentiation, the what the mathematics source will give. Okay, such type of formula we verify, sir, and practically we learn that in mathematics, sir. No problem, sir. No issue. First, where you use this concept, you explain here, sir. Yes, coming to that, where I am going to use in my physics particularly. Okay, coming to here, I am saying the velocity is suppose changing with the respect to time. Okay, if that change is uniform, then uniform acceleration formula we use. What v is equals to u plus at. But I don't know whether it is uniform or non-uniform. That's why I have to go through mathematics. So velocity represented with the letter v as a function of time means he is saying that v is a function of time. Okay, that one, the rate, how to write, I think you understood. Ah, okay, no problem, Nana. Yeah, exactly, Tanisha, correct. Rate, v is changing with respect to time, that is with respect to time in the denominator, changing d, and here v. Okay, good. And don't cancel d and d here, and don't say v by t. Ah, a bit low, Nana, it's true, it's true. Okay, there is some issue in Zoom. I think after getting the update, I found this problem. Later, I think this bug will be fixed by Zoom only. Okay, now. Yeah. So don't cancel, Nana. This dt is whole single term. D is a separate term. That's why don't cancel. This is like a sine 30 by sine 60. Okay. Then we won't cancel sine and sine, and we write 32s are 1 by 2. Now, is it correct? I think all of you laugh. Is sine 30 by sine 60 half? Nana. Sine cancel 32, sir. No. In the same way, here we should not cancel d and d. Okay, na? Good. So come to here again. This dv by dt is what, sir? Yeah, right. dv by dt is what, sir? Rate of change of velocity. You know, according to our definition, he is none other than acceleration. So to find out the acceleration, this rate formula I use. Okay, applying the mathematics. So will you remember this formula for acceleration, Anna? Rate formula? Okay, yes, right. Keep in mind, this is one formula. Formula number one. Okay, number two. Suppose he says the velocity, okay, is changing with respect to displacement. If those changes are uniform, we use the formula v square minus u square is equal to 2as. But I don't know. Again, yes, exactly, Mr. Pawan Kumar. Okay. Velocity, I am taking it as v, and displacement, I take it as s. Here we write, means v is a function of s. Okay, no problem, Manikanta. Okay, no problem. V is equals to function of s, Nana. This one, already Pawan Kumar posted the value, and all of you know that. Changing with the displacement means by ds. Who is changing? V. So d of v, dv by ds. Okay. This actually, not to say something here, nothing is there in our physics, Nana, physical quantity. That's why to get some physical quantity from here, what I'm going to do, this one actually velocity is meter per second. Okay, displacement is meter. So if I cancel, I am getting 1 by s, second inverse. That's why if I multiply with meter per second here, meter per second into 1 by second, I will get meter per second square. Meter per second square, who is this, Nana? It is the unit of whom? Acceleration. Very good, acceleration. That's why to get the acceleration for this part, yeah, I am multiplying with meter per second. Meter per second means velocity. So into velocity I am taking here. Okay, velocity into dv by ds, I am getting meter per second square means acceleration. That's why it gives the acceleration. Second equation, try to keep in mind. Okay, so will you remember the second equation also, Nana? Okay, good. Will you remember or not? Yes. So for acceleration, till now we got two equations. One is dv by dt in mathematics, using the mathematics, and v into dv by ds, second mathematics formula for acceleration. Very good. And now coming to the next page. Here, still where you use, yeah, look at here. Suppose someone says the displacement is changing with the time. Okay, in case of uniform, you know, s is equals to ut plus, yes, very good, s is equal to ut plus half a t square. Whereas here I use it is as a function of time. That's why I write it as by dt change d of x. Okay, it is mere appeared like displacement by time. That you know, Nana. Displacement by time gives velocity. That's why here it gives velocity. So for velocity, we found one equation. Okay, right. So this is the third rate equation, right? Try to remember the third equation also, Nana, for velocity. Sir, I don't want velocity, sir. Where V is velocity, Nana. I want speed, sir. Okay, no problem. Which error, Nana? Is there any problem in voice? Charmi Priya. Okay, nothing error, Nana. All they are seeing. Nana, all of you able to see my whiteboard? Voice a bit low. That is okay. I accept. Yeah, yeah. Once you check, Nana, board is clear only. Yes, yes, yes. Okay, no problem. Okay. Instead of velocity, sir, if I ask speed, then very simple. In case of speed, we try to take the change of not displacement, distance. That's it. Yeah. Uh, yeah, very good. ds by dt, same thing I write here. Okay. But where s is distance. That's it. Okay, so here to find out the speed, I'm going to use this formula, fourth formula, same like velocity, but there s is displacement and here s is distance. Okay, these are few equations related to the differentiation now. Okay, right, good. So here, while using these equations means a bit differentiation from mathematics. Okay, when there is a function, okay, which is varying with some other variable, okay, then how to calculate the values. Okay, for them, from differentiation, few useful formulae we are dumping on. Okay, not from dump air, dumping from mathematics. Okay, so those formulae here, what you have to butify formulas. Okay, yeah, here, like how you buttified in mathematics, sine square theta plus cos square theta equals to 1 cos 2 theta is equal to 1 minus 2 sine square theta. Like here, few formulae in differentiation. Okay, so will I start the formula, Nana, here? And will you buttify them today? Yeah. Why? Because tomorrow we have to use them. Okay, more frequently. Yes, good. Try to buttify them today. Yes, those formulae I am saying here. For example, everything I am writing with respect to x, Nana, I am taking. Okay. Suppose if y is given as a function of x, okay, then I am writing one by one the formula. Okay. First one, suppose given as y is equals to, okay, only x, right? Then what is the formula? Then here I am finding out the trace, changing d of y. Okay, this is a common formula, Nana. In this formula, every time you have to substitute what is the value given. Very good, Amok, correct. I think you learned that in your lower standard. Okay, somewhere in tuitions. Okay, or in corporate colleges, I think. Yeah, good. So here every time you have to substitute this y value what he gave Nana. Okay. So here I am writing here d by dx of, in the first model he gave y is equals to x. Okay. If you get this type of term, okay, means x power 1, that equals to 1 Nana. Keep in mind both must be same. Okay. Sir, not understood properly, sir. Okay, then go to second one. I think here you will get some clarity, right? Come to here. Suppose y is given as, every time I'm taking function of x only. So x power some value like a 2, 3, 4, so on, some n. Okay. Madhuri, Mehar Madhuri. Okay, right. Y equals to x power n. Then this one, what is, yes, correct, I'm correct only. Okay. This one you have to remember now, not n na Manikanta. Okay, d by dx of y, in place of y I am going to substitute x for n. This formula is actually the fundamental formula, Nana. Keep in mind. X power n, yes, provided these two terms are same. Again check. Yes, sir, those two terms are same, sir. Then write here the formula n into x power reduce 1, n minus 1. Yeah, nx power n minus 1. Okay. Now you can check the above one with the fundamental formula. X power here given how much? 1. 1 means n value is 1. That's why here, right? N means 1 into x power n minus 1. N is 1, 1 minus 1, that is 0. This is equals to, you can see here, 1 into x power 0. X power 0 is always 1. All of you know that. That is 1. 1 into 1 is not 11. That is 1. That's what I wrote without this explanation. So now you understood the first and second, Nana? Yeah. X power, yeah. Good, good, good. Yes. So out of these two, the second one is the basic formula, fundamental formula. Okay. So the second one is the fundamental formula. Yes, good, good, good. Then here, suppose third one, what I have to remember, sir? Yes. If y is given as a function of x, okay, as log x, keep in mind, Nana, log, if I write like this, that is base 10. Log, if I write it as ln, keep in mind this is log base e. Okay, so try to understand these two. If you are very good, went through previously the scientific calculators, there's, you can see these two buttons, symbol buttons. Okay, scientific calculator, one with the ln, other with the log. Yeah. Log stands for base 10, ln stands for base e. Okay, next time I won't explain, Nana. ln, if I write, you try to understand. Oh, that is base e. Okay, and that too I think thermodynamics started there on the, in the other track. There this ln many times you will get in thermodynamics. Okay, so it may be helpful to you. No, then what started there in the second track? Not thermodynamics. Okay, no problem, whatever it may be. Thermal properties, oh, not yet completed. Okay, right. Then in that next chapter it will be helpful to you. Okay, right. For this, Nana, here I am writing, if y is given as log x, d by dx of y is log x this time. Formula is 1 by x. Again, every time check the two functions are same or not, x and x. Okay, 1 by x. This is one formula that what you have to remember. Okay, so second one, it is completely different from the second formula. Okay, you have to remember. And then here, suppose fourth one, sir, trigonometric functions are given, sir, then what to do? Okay, all the trigonometric functions not required, particularly in the initial days, Nana. That's why few which are required I will explain. Okay, so better first we order plate meals, then we go to full meals. Okay, first day we try to take few formulae, later we will take total formulae. Yeah, yeah, yeah. That Sharat sir will explain, Nana Manikanta. No problem. Don't worry. All right. That is using a little bit mathematics, not using this formula. Okay, na? Yeah, y is equals to here, suppose given as function of trigonometric, yeah, sine x, Nana. Okay, sine function given. Then what will be its rates are differentiation d by dx of y is sine x. Again checking, both are x only, happy. Then this is equals to formula, try to remember, this is cos x. Yeah, yeah, good, cos x. This one also you have to remember for our physics formulae, means physics problems, right? And next one, I am going to here, suppose fifth one. Here I am writing. Okay. Y another trigonometric function. Another trigonometric function y is equals to given as cos x. Okay. Right. I think Tanish also knew all these things in 10th class or somewhere in lower standards. So here the rate I am taking with respect to x, d by dx of cos x. Okay, this one again x same functions. This is minus sine x. Again, don't ask why you got negative sign. That you can understand in mathematics. Okay, right, good. So this is one more formula, Nana, here. What you have to remember, right? And next one, sixth one, what we have to remember, y is given as a function of exponential, like e power x. Okay, then here d by dx with respect to x, e power x, again x same functions. So here the value is e power x only now. For e power x, the differentiation is e power x only. Okay, right, good. E power x. This is one more formula here. Okay, right. E means exponential, Nana. Okay, exponential power x means exp, generally we write. Okay, exponential function of like right, exp x, that simply we write it as e power x. Okay, good. From these formulae here, right, how to apply them in our physics? Okay, before starting, Nana, just cross checking you all. Suppose if I write the seventh one here, okay, y is equals to some constant k. K is a constant, like, oh, Amok, super, good. K is a constant like a 2, 3, 4, some number, none, constant value. Okay. In that case, If I write rate d by dx of y, yeah, Tanisha, correct. D by dx of k. Okay, this one constant never change, Nana. Constant never change means there is no change. No change. We say with this, we represent with zero. That's why anywhere in numericals, either maths or physics, the differentiation of constant, if you get anywhere, directly you can put the value as zero. Okay, Nana? Keep in mind, only k, not along with some variable. Not like y is equals to kx. This is again different, Nana. Okay, y is equal to 2 is different, y is equal to 2x different. Okay, understood? So this is valid for y is equals to 2 or y is equal to 2x. This one, y is equals to 2. This is valid for 2. Not with some variable. Without variable, better I write here. Without variable, a variable. Okay, without x or some other z or t, without that one, then you can say it is 0. Okay, if there is a variables are how to write those, we try to practice now. Okay, the different things basing on these fundamental formulae we try to practice. Okay, so we are going to start the practice here to get some grip on this formula. Okay, come to here, we are trying to get some practice. Okay, number one, suppose here, better I go to the next page. Here, I am writing. This is one example, Nana. Okay. Suppose I say the displacement changes with the time as s is equals to t square. Okay. Find the velocity here. Okay. Find the velocity at a time of t is equals to 2 seconds. Okay. So here nothing to worry, Nana. Don't worry. Simple. Okay. Displacement as a function of time given. He is asking velocity means, for your sake, I am turning the pages back. Here, look at in the second page. If s is given as a function of time, very good, Amo. Pawan Kumar, very good. Pawan Kumar, today I am seeing good response. First day. Are you a new person, Nana? Oh, it is Gayatri. Oh, sorry. Already you remembered. It's my mistake only. Sorry, Nana. Gayatri, Lakshmi Gayatri. Yeah, yeah, yeah. Here, look at this is velocity. E already I gave the formula here, Nana. That is d by dt of s. Okay. This formula to find out the velocity here I am going to use. Why I am going to use, I explained there. Why? Because displacement is given as a function of time. Okay, Nana? Yeah, come to here. According to the known formula, yes, yes. According to the known formula, V is equals to d by dt of s. Okay. Come here, substitute the value of s, Nana. D by dt of s is t square. This is exactly in the form of x power n. Okay, d by dx x power n. Look at the two functions are same. Again here also I am checking. T, same functions. Happy. Directly I use the formula n x power n minus 1. Okay, Means here n is 2, x is t, power n minus 1, 2 minus 1. Okay, so look at here what I'm going to get. V is equals to 2, t square minus t power 2 minus 1 is t power 1. Okay, you got actually using the mathematics. This is mathematics part. Okay, over. But he is asking that velocity at t is equals to 2 seconds. T is equals to 2 seconds means his intention is you have to understand substitute t is equals to 2 there. Okay, that implies v is equals to 2 into yes, correct, 2 into t is equals to 2. 2 into 2, that is equals to 4 in those units, known units only he gave, so I am writing here meters per second if he gave here in meters. Okay, right, if he gives this one in centimeters, we write the answer centimeter per second. Okay, Nana, did you face any trouble here in understanding this problem or understood this one? Yeah, no trouble. Okay, good. No, sir. Understood. Very good. Very good. That's simple, Nana. Very simple. Okay. Uh, okay, Nana. Satvika. Which last this at t is equals to 2 seconds, Nana. Where it's simple, Nana. Actually, your answer is over here. You sorry. Actually, your answer is over, Nana. Mathematics part is over. We differentiated and got the velocity. Okay. Means we have to stop the problem here. Actually, right? Just he extended the question. Find the velocity at a time of t is equals to 2 seconds. So in this time t, we have to substitute 2 seconds. That's it. What is that? Yeah, yeah, yeah. Good. Right? Ishan boy. Understood now. You understood, Mr. Ishan boy. Then here, come to the next model. Okay. Look at here. Better you use Dipali earphones, Nana. Why? Because I can't do anything. Yeah, yeah. Okay, right. Good, Mr. Ishan boy. Then here, better use earphones, Nana Deepali. Why? Because after updating only I found this problem and I can't do anything. Okay, good, Charmika. Hey, very good name. Charmika Unnava. Okay, Unnava, right. So here, coming to, good. So here, suppose next example, if I give like this. Um, yeah, that's correct, correct, Nana. I'm facing the same issue with all. Okay, unnecessarily I updated, and after updating, I found this problem. Okay, and I can't roll back this update. So we have to bear until we get some next update. Okay, na? So please bear for few days. Surely we get some next update, and then we won't face this kind of problem, I believe. Then here an example. Look at. Suppose if I say in the above problem, means same problem in the above example. Don't worry, we may get very quickly, I think. In the above problem, if I ask, find the acceleration. Wow, Amok. I don't know, Nana Ishan. It is my original sound only. Even though I am getting a little bit low. If I turn off the original sound, you will get very low voice. That's why I'm using this original sound only. Ah, right, right, right. Find the acceleration. Acceleration zero, Nana Lakshmi Gayatri. I don't think it's so. Look at here. Acceleration. I'm turning back again. Suppose with respect to time given in a question, then acceleration is equal to our formula d by dt of v. Okay. So if I go to d by dt of v, yeah, this time it is correct, Manikanta. Okay. So acceleration using the known formula, a is equals to dv by dt. Again, don't ask why you use with respect to time. Why? Because in the above problem we got v is equals to 2t. That is a function of time. Okay. Uh, from the above example, yes, good, good. From the above example, here I write where I got v is equals to 2t. That I am going to substitute here. That implies a is equals to, I write d by dt of v, I got 2t. Yes, here you have to understand one point, Nana. Okay, this is called practice. If there is a constant in the form of multiplication, that constant can be taken out of differentiation. Okay, means what I am going to do here, 2 is a constant and checking it is in the yes, it is in the form of multiplication. In multiplication the constant can be taken out. That's what I'm repeating, Nana. Okay, here no problem. 2 here taken out since it is a constant and it is in the form of multiplication. Okay, good. Then 2 taken out. What is left there inside? Only t. Okay, both are same terms, power 1. Already I explained here. If the power is 1 and same terms, you will get it is 1. D by dx of x is 1. In the same way, d by dt of t is 1. Okay, right, good. So this is 1. So it is 2 into 1, that is not 21. It is equals to 2. Therefore, I got the acceleration 2. All these are given in meters and seconds. That's why meter per second square. Okay. Yes, yes, yes. That's my next question. Is it constant acceleration or variable acceleration? Constant acceleration you got here, Nana. Okay. Here it is a constant, means this is exactly in the form of s is equals to ut plus half at square. Okay. Sir, once you check, sir. Yes, I will check. Okay. Next page. I am turning to next page. Here. Right. Note. Given that s is equals to t square, square of time, it is, yeah, good, good. Now you understood, Mr. Abok. It is in the form of s is equals to ut plus half at square. Sir, here exactly write the above equation, sir. Look at that is how I am writing. Observe keenly here. S is equals to u. I am putting 0 into t plus half. A I am writing 2 into t square. Look at here, is this equals good afternoon, Anna? Okay, I think you went off and again joined. Okay, yeah, yeah, half a t square. Okay, so here if you check, this is exactly okay, no problem. That implies s is equals to t square, exactly the given equation I got here. Okay, that one I am writing in this form means, suppose if they ask bit low nana. Okay, that is a common issue. And here, look at in the same question, if they ask, that implies, will you say the initial velocity? Fine. Initial velocity. From this equation, you can say by comparing with ut plus half a t square, u is 0, or you can go back and say the answer here using the differentiation method. Okay, in this formula, okay, here you can write note. Okay, yet t is equals to 0 means before starting. Okay, before starting t equals to 0, put t is equals to 0, that doesn't become 20 nana. 2 into 0 is 0. That implies v equals to 0, means initial velocity is 0. Non-uniform acceleration nana. Okay, I'm explaining non-uniform acceleration. So there and here, using the differentiation method, fortunately here we got a is equals to 2. So using that equation also we got initial velocity 0. In both the methods we got the same. Okay, non-uniform nana, right? And look at, once again compare, in place of a what is there? 2. Okay, and acceleration equals to 2. A is equals to 2. You turn back and see there how much you got here acceleration, 2 or not, using the differentiation method. Okay, so once again proved that the differentiation method and uniform acceleration formulae both are valid, and this differentiation can be used even though the acceleration is constant. So did you catch my point? This differentiation method is used not only for non-uniform acceleration, even for uniform acceleration you can use. Okay, yeah, 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 correct. Right. Good. Those points here I am writing what the concepts we learned from the above example. Okay, the concepts here, today it is Friday now, so better I write in green color. Okay, concept. Okay, that is number one, what the concept, yeah, thank you. One, I am writing the differentiation can be used. Yeah, thank you. Can be used. Okay, better I write it clearly. Can be used for uniform or non-uniform acceleration or velocity in our physics. Okay, you can use it for uniform velocity, non-uniform velocity. You can use it uniform acceleration. Yeah, yeah, yeah. Uniform acceleration, no problem, Nana. Uniform acceleration and non-uniform acceleration. That is one concept what we learned from this. Okay, and number two, Number two, here, observe. A is equals to what I wrote, Nana? dv by dt. Am I right? Okay. Yeah. A is equals to dv by dt. Okay. Keenly observe what I am going to write. By dt into d of v. I am going to write again d of s by dt. Okay. This v formula I am going to substitute. Yes, yes. This v formula I am going to substitute there. V is again d by dt of s. Okay. This whole thing, how to write, sir? This whole thing, how you write clearly, sir? Very simple. That implies I write it as A is equals to d of d, that is d square, two times I used, into s means of s. Yeah, exactly. That's what I'm going to write. D square of s, okay, divided by here dt. The dt comes to the denominator, Nana. dt into dt is dt whole square. That is already a single term. That's why straight away you can write it as dt square. So acceleration you can write in the other form like this. What's a is equals to, okay, d square s by dt square. Okay. Once have a small recap, Nana, here. Acceleration today we found a is equals to 1 is dv by dt, d by dt of v, and number 2 we got v into d by ds of v, and third one we got here, that is equals to d square s by dt whole square, that is dt square. So understood this one, Nana? All of you? Yeah, good. And here, Nana, every time you are few in the chart, they are asking the important questions for IP exam. And those important questions you ask Amol sir, Nana, he will provide the important questions for both the tracks. Okay. So better you ask Amol sir, he will give the important questions to you all. Okay, na? Good, good, good. No problem. Right, here. That's it, Nana. From this concept, what we learned. Right? And keep in mind, I did not give any questions to anyone. Okay. Okay, okay. I did not give to anyone. I don't know, Nana. You ask directly that person only. Okay. Now you can see the pages here. Okay. If anyone want to take first page, then this is the second page. Okay. Bye, Nana. Okay. Thank you. Thank you. This is the third page. Okay. This is the fourth page. That's it, I think. Yeah. Yeah. Bye, everyone, Nana. Tomorrow we will practice more on this. Okay. Good. Bye, everyone.